So you might wonder, why would you need to use machine learning for search? So let's try to understand what happens when you create a scoring formula for search. So as you have seen earlier, the scoring formula for search results consists of a weighted sum of factors like raw score from search engine, then behavioral data like clicks, popularity, and dock age. So the weights conventionally that you see here, like 0.6, 0.4, 0.2, 0.1, if you don't use machine learning, they are usually hand tuned, which requires a lot of manual intervention. Let's understand how. So the way you start with designing the scoring formula is you start with some human judgments, ask them to grade how good a result is for a given query, and based on that you hand tune your weights, and then you compute the search results. Then you compare your actual results with what is predicted from your search engine, and if they are away from the actual results, predicted actual results, then you again adjust the weights and again continue the process. So you continue this whole process until you minimize the error between the human judgments and the search engine, which are predicted by your search results, which are predicted by your search engines. So this process, if you don't use any machine learning, it's very manually intensive, requires days of work, maybe multiple programmers who has to really parse through and understand the search results, understand the heuristics, understand the patterns by visually looking at data. And unfortunately, humans are not as good as machines at this problem. So the challenges here are basically it's human intervention is required, labor intensive work. You are not able to scale because it's going to take many days to fine tune your results. So how can machine learning help? So with the help of machine learning, what happens is, first of all, the judgment itself, you can just collect it automatically from the live data itself using a learning to rank plugin, right? So you may or may not have to do manual judgments, but if you do manual judgment, that's well and good. But over a period of time, it's best to get the actual judgments by observing what results users are clicking for real queries. And you can get a massive data set just by starting logging the feature using learning to rank plugin. So again, you start with some initially to bootstrap, you start with some weights, and then you get search results for the input queries. And now what you do is you feed the search results from your search engine to your ML training along with the judgment results, and your ML training will create a model which can predict those weights for your search engine. And again, you compute the results. The ML training will compute the model in such a way that it reduces the error between the actual and predicted. And ML training can you use linear, non-linear, or a tree-based model to do this, and it scales really well, and it does this at a rate which is much faster than human beings. So the advantage is you are automating your weights for your search ranking results, and you can scale it very easily with multiple machines, and you can do all of this in a very short time. That's where machine learning is very powerful. Another advantage of machine learning is, let's say again you compare with a human tuned relevance. The relevance could change over a period of time because of the change in users behavior, right? So even if you hand tuned it, you might have to tune it over and again if you see a drop in your relevance. With the conventional, with a machine learning approach, you can just retrain your model with the new judgments, with the new behavioral data that is coming from the real users, and your model automatically adjusts to the new behavior of users without requiring any manual intervention. You can just automate the process so that every 6 months or every 1 year you can retrain your ML model with a new set of data. So that's where the power of machine learning comes into picture. Now let's understand the difference between classic ML and ML for search In classic ML, conventionally the problems are classified into either regression or classification. In regression, what you do is you predict a real value output. Like, let's say if you are predicting a stock price, the stock price would be an actual output based on its historical values. In classification scenario, you predict a certain category or multiple categories for a given set of images. Let's say you are detecting a cat or a dog inside an image, so you predict that category. In case of search, the problem is you are not predicting a real value, or you're not classifying a result into a certain category, but what you are doing is, for a given query, you're computing a set of results, and that set of results you are comparing with ideal set of results and see how close they are. So usually you use a metric like recall precision or NDCG or expected reciprocal rank to make sure that error is minimized between the actual and predicted results. And we will see in the subsequent lectures on how we can use machine learning library to minimize those errors. Okay, in search, typically you use three types of models: tree-based model, SVM based, or linear models. In tree-based model, you use either a decision tree or it's an ensemble of certain decisions. You can also use XG based model. These models are usually expensive to train, but they are very accurate. Then SVM bus model, where you used support vector machines to predict whether the user will be able to click or not click certain results, and based on that you classify the results pairwise at a time. And SVM based are cheaper to train but less accurate as compared to tree based model. And the third one is the linear based model, where you can also use your linear regression for training ML models, but this doesn't work beyond a few training examples. So in the subsequent lectures you will learn about more about how can you go about configuring your search engine to start using machine learning, how can you train your models using a machine learning library, and then how can you actually start searching with that ML model that you have just trained.